Hello and welcome to my keynote about RFID solutions using LoRaWAN. My name is Sascha Jeklev from Parametric here in Switzerland. I like to explain how NFC and RFID work, show the differences and limits of different techniques and how it could be used in combination with LoRaWAN. You will get some use case ideas of real-world solutions using both NFC and LoRaWAN. Ready? Let's get started. We start by first defining NFC and RFID. RFID and NFC fit into the broad definition of wireless communication technologies. As with every wireless technology, the idea is to transmit data from one point to another without using physical media or wires. Wireless communication is generally done by using electromagnetic waves, where data is modulated onto a carrier on the transmitter and demodulated from the carrier by the receiver. RFID stands for radio frequency identification. A reader can read a passive or active RFID tag. NFC stands for near field communication and is based on the RFID technology. NFC can transmit data in both directions. This enables more applications that needs communication between two devices, or between a reader and a tag, or between the tag and the reader. RFID tags can be categorized into three frequency ranges. Low frequency tags work in the sub-megahertz band at 125 kHz. These tags are mainly used for door openers or livestock applications. High frequency tags include the family of the NFC tags. Because of the possibility of reading and writing data, these tags are very interesting for a lot of applications. We will show you some examples later on how it can be used. If you are buying clothes or electronics, you will probably have an ultra-high frequency tag on the packaging. These tags can be read from a wider range, allowing theft protection or fully automatic accounting of your entire shopping cart. But why is Parametric using NFC? NFC is a very flexible technique when it comes to applications. Tags can be used with just a pre-programmed serial number or with up to 64 kilobytes of user data for complex applications. You don't need a reader hardware to get started. As a rule, current smartphones are equipped with NFC. So you only need to install an app to program your first NFC tag. As always, in the real world, there are several different tag variants, which differ by their memory, size, transmission modulation type, and data encoding. There is a huge market for NFC tags for every conceivable application, including completely sealed glass tags or rugged tags that can last up to 200 degrees Celsius. Let's show you some hardware. NFC uses an inductive coupling between NFC devices and operates with an electromagnetic field at 13.56 MHz. This is a license-free allocation in the radio spectrum. An NFC device can draw power from the field generated by another NFC device. The technique has three modes. Reader-writer mode, where the reader is the initiator of the communication. Peer-to-peer, where the data is transmitted between two active devices, such as smartphones. Or the tag emulation, where the NFC-capable device is simulating a tag. Let me show you something really cool. Here we go. This is our newest product. It's a RFID LoRaWAN reader. It's the first time that we show this device on public. So you can be very proud of attending this keynote. Our brand new LoRa NFC reader can be used as a bridge between the NFC and the LoRaWAN technique. The device reads NFC A and B tags and much more to come, and it stores the content in an internal data buffer. Then it tries to send as many of the buffered readings over the LoRaWAN network. This can take some time on low data rates. The device is available now in small quantities. Please see the link below where you can get more information or order a sample. The battery-powered version will get ready beginning of March. If you are a supplier of goods, you are interested that your customer orders exactly the same article again and again. The idea is install him a LoRaWAN NFC reader to get it very easy for him to reorder. Let me show you some examples. An NFC tag can contain 0 or more so-called NDEF messages. A message includes one or more NDEF records. Think of it like a simple file system. On the other side, we have LoRaWAN with its maximum payload size limitation, depending on the current data rate. If our device currently is running with data rate 0, payload length must not exceed 51 bytes. When with data rate 4 or better, the payload size could be a lot bigger. This is the payload format of our reader. You will see that we add one or more scan records to the payload. Each scan record contains a scan time, the NFC serial number, and a record payload. To simplify matters, we always copy all data from the first NDEF record to the LoRa payload. So far so good. The problem is now that data length stored in the NDEF record is of variable length. On the other side, LoRaWAN payload length is also variable. Our strategy in the device firmware is that we put as many records as possible onto the LoRa payload. This leads to the fact that we end up with a LoRa payload that comes with different lengths. Too complicated? Too fast? You can find all the information on our product website to read through it in peace. But there is another problem. If you need a solution for COVID-19 contact tracing, you could also use this device. Have a look. I hope it was interesting for you. If you have any questions about our solutions or our products, or especially this product, feel free to contact us. You will find all informations below. Thanks. Bye bye.